The empirical rule is a useful, just sort of rule of thumb for when you're interested in how many observations fall within 1, 2, or 3 standard deviations from the mean. But what if we're interested in a value in between, say 1.5 standard deviations above the mean? For that, we're going to have to use some kind of normal distribution calculator. There's lots of these available, and if you're already comfortable with one, maybe like a TI-84 calculator, something like that, feel free to use it. But I'm going to show how to use the JUMP distribution calculator. So before we start, we need to install the calculator really quick. You only have to do this one time. So first, go ahead and open up JUMP. Then go to ELC up here at the top where it says JUMP and pick Distribution Calculator. It may take a second, but it'll automatically download it. So I'm just going to click Open down here. And then when this pop-up comes up, I click Install. And that's it. So now if we come up here and go to Add-ins, you should see an option for teaching modules and then distribution calculator. By the way, there is a reference sheet if you want to use that for JUMP, and the instructions for how to get this are on the reference sheet. But one more time, it's just add-ins, teaching modules, distribution calculator. So we're going to be answering some questions about IQ scores. So I'm going to start by putting in the mean and standard deviation. So 100 for the mean and 15 for the standard deviation. And you'll know it works because you can see how the axis has been updated. And the first question in the note says, what proportion of people have an IQ score lower than 75? So I actually recommend that you do go ahead and draw a picture every time. You don't have to label it, but I'm going to go ahead and do it just for illustration. So let's mark the graph to represent people with an IQ score lower than 75. So I'm finding 75 here and shading to the left. So the reason I recommend drawing a picture is that you already have a pretty good idea of what the proportion should be. So for example, if you got a number that was over 50%, you would immediately know that something had gone wrong. So I can't tell you how many times drawing a picture has saved me from trusting a wrong answer. So I'm going to go to my distribution calculator. I'm going to type in 75 for my input value. And I can see that this matches the picture that I drew. So this is the right probability, 0.0478. So that's the probability of having an IQ score lower than 75. What about an IQ score higher than 107? So again, I'm going to draw it here. So immediately I can tell that the probability will be bigger than the last one, but smaller than 50%. So I'm going to change my input value here to 107. But I see that this doesn't match my picture. Also, it's giving me a probability that I know is too big. So I'm going to change it here to the greater than option for the probability options. That matches my picture, so that's the right probability, 0.3204. What about the people with scores in between there? So between 75 and 107. So here I'm shading this section in between. And JUMP has options for this too. So this one requires two different input values. So the catch here is that you always have to put the smaller number in for value 1. So if I try to do 75 here, it'll freak out. So I've got to put 75 in for value 1, and this is shading that area in between. So 0.6318. That's my probability for this area in between. Actually, I could have found that based on the information that I was already given, because I do know that this has to total to 100%, so it has to add up to 1. So another way to find this would have been to do 1 minus 0.0478, because I don't want to count the people lower than 75, minus 0.3204, because I don't want to count the people that are above 107, and that would give me the same answer, 0.6318. JUMP also has the option to shade in the tails. So if I click this last option, it's shading out beyond value 1 and value 2. And honestly, I find this notation a little bit confusing. So that's another reason why I emphasize just drawing a picture and then making sure that what JUMP is doing matches your picture. The next one says, Mensa accepts applicants whose IQs are in the top 2% of the population. What is the minimum IQ for the club? So I want to find the point here where 2% are above and 98% are below, right? I'm looking at that top 2% of people. This is also called the 98th percentile. So if your score is at the 98th percentile, that means that 98% of people have scores lower than yours. So notice this is a very different type of question. Earlier, they were giving us IQ values and asking us to calculate percentages. Here, you're being given a percent and asked to calculate an IQ value. So you're basically using the distribution calculator in reverse. So before I start here, I'm going to change my type of calculation. Now I'm going to input probability. So we're looking at 2%, but I have to put this in as a proportion. So I'm going to do 0.02. But notice this is showing the bottom 2%, and I'm interested in the top 2%. So I'm going to change this to the right tail probability. So if I round to the nearest whole number, this gives me an IQ score of 131. So a person with an IQ score of 131 is at the 98th percentile. There's also a few more percentile options here. We can do the central probability. So this is showing that middle 2%. Obviously, you could change the value here. Or you could do the two-tailed probability. And this is giving you 2% out in the tails and what the cutoff would be for that. So at the bottom of the page, there's another example for you to practice on your own. And the Google Forms will share the answers and feedback.